All right, Algebra 1A students, welcome to part 3 of our lesson 6.3 on solving systems of equations by elimination. In our last two videos, we've been looking at solving systems with the elimination method, where we have been adding or subtracting two equations together to eliminate one of our variables. In this video, we're going to do the same process, but we are going to add one extra step to that process. Okay. The reason we have to do that is because the elimination method gets harder when none of the numbers are the same. Okay. We've been looking in our equations for some numbers that have been the same. Unfortunately, that's not always the case. Okay. Numbers are not always the same when you have a system of equations. So what we have to do is we have to multiply every piece of one of our equations by a certain number to make two of the numbers the same so that we can eliminate. Okay? So we're going to solve this problem basically by multiplication. And we just have to make sure that we multiply every single piece of one of our equations. Okay? Now, if we look at this example problem, here is a system of equations where we have x's and y's and numbers, obviously, but the thing I want you to notice is that none of these are the same. None of the numbers are the same on my x or y, so I need to multiply one of my equations by a number to make two of my values the same. Either my y values be the same or my x values be the same. So if I look at my y values, I see that this bottom equation has a 5 on the y. This top equation has a 15. The nice thing for me is that I can turn the 5 into a 15 by multiplying by 3. If I take this second equation and multiply every single piece by 3, that equation will now say 21x minus 15y is equal to 3 times 17 is 51. The top equation is going to stay the same. It's still negative 2x plus 15y equals negative 32. And now I have these two equations instead. Okay, so this system is still exactly the same. I haven't done anything except multiply the entire second equation by 3. As long as I multiply every piece of an equation, I can multiply by any number I want. Okay, as long as I multiply every single piece of the equation, I can multiply an equation by any number I want. Now, the reason that I've done this should be obvious to us. It's because now, if I look at my 15s, they're the same number, and I can eliminate my 15s by adding the two equations because the sign is not the same. This sign is different, so I'm going to add the two equations and eliminate. Now, negative 2 plus 21 makes 19x. The 15s are gone, and the other side of my equal sign is negative 32 plus 51. If we use a calculator for that, we get 19. All right. The nice thing here is that if I divide by 19 on both sides, I get that x is equal to 19 divided by 19, and 19 divided by 19 is 1. So x equals 1. Okay. And now that x equals 1, I can put that back into either one of my equations and solve it for y. So if I take the 1 and I put it back into that original equation, it ends up saying 7 times 1 minus 5y equals 17. So then obviously this says 7 minus 5y equals 17. And if I solve, negative 5y equals 10. and then I just have to divide both sides by -5, and I get that y is equal to -2. Once I have this, I can write my coordinate point, parenthesis 1, comma, -2, and I have my solution. My final answer is here. Okay? So once I multiply the equations, what you see on this screen should look exactly like what you've been doing with elimination this entire time. Nothing really is different, except that I have to do this extra step of multiplying every piece of an equation by a number to make that number equal one of my other values. Okay? I would like you to try that with this system of equations. -5x minus 2y equals 6, and 3x plus 6y equals 6. And I will say you should be multiplying one of your equations by 3 to make the numbers be the same. I would make the y's the same and then eliminate. Okay, so try that. Multiply your equations by something, eliminate a variable, solve, and then come on back and I'll show you what we should get. Okay, when I multiply the top equation by 3, I should get -15x minus 6y equals 18. And now again, I have 6y and 6y. One is positive, one is negative, so I will eliminate by adding the two equations. Okay? If I add the two equations, the 6y's go away. -15 plus 3 is -12x. 18 and 6 make 24. So I get 12x equals 24, excuse me, -12x equals 24, which leads me to x equals -2. If x is -2, and I plug it back in to, say, this equation, I get very quickly that y is equal to +2. If you have questions about solving systems by elimination when we have to multiply, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.